Hey, mathematicians, we're going to finish up this year talking about systems of equations. We just got a couple of days left here. So enjoy your last couple of sections here. I hope you had a good year. So a system of equation is going to be is two or more linear equations. So there's going to be two variables. If there are three equations, three variables, and so on and so forth. We're just going to be focused on two variable in this chapter. So a solution is the one that works for both equations. So if you remember, a linear equation itself by itself has an infinite number of solutions. And then the other one would have an infinite number of solutions. But there's exactly one that works for both of them, which is interesting. I really think about that. Infinite. There's a bajillion possibilities, infinite number of possibilities for this equation, and there's an infinite number of possibilities for this equation, but there's only one that works for both. Same with all of those. So it's interesting. So the first thing we're going to be looking at is an ordered pair a solution to both of these? So we're going to plug in 12 and 6, and it's got to work for both for it to be a solution to the system. So remember, the first number is the x, the second number is the y, or we're just going to plug it in. So that would be 2 times 12 minus 3 times 6. We want to know, does that equal 6? So that's 24 minus 18, which is 6. Those work, so that one works. That one's good. Second one, x is 12. We want to know, does that equal 2 times y, which is 6? That one clearly works. So since they both work, and it has to be both, yes, it's a solution. If one of them doesn't work, it's not a solution. Let's look at the next one. Okay, again, my 4, this is 12. We'll plug it into the first one. So 4 times x, which is 4, minus y, which is 12. Does that equal 2? So 4 times 4 is 16. 16 minus 12 is 4. Right there, no, it doesn't work. So since the first one doesn't work, I don't even need to try the second one. No, it's not a solution. So if the first one doesn't work, don't even matter what the second one is. Okay, number 3 down here. This is my x, this is my y. Plug it into the equation. -1 plus 2 times y, which is 2. Does that equal 3? So 2 times 2 is 4. -1 plus 3. -1 plus 4 is 3. So that one works. Let's check the second one. 4 times -1 minus y, which is 2. Does that equal 6? So -4 minus 2 is -6. Those do not match. So no, it's not a solution to the system. Okay, last one, number 4 here. This is my x, this is my y. 2 times 2 plus 1. Does that equal 5? 4 plus 1 is 5, so yes. Second one. 2 plus 3 times 1. Does that equal 5? 2 plus 3 is 5. It works, so yes. It's a solution to the system. How exciting. All right. So that's a pretty simple objective. We're just plugging things in. So the last thing we're going to look at, we're skipping objective 2 today. We're going to come back to that tomorrow. That's where we're going to be graphing some things. When you do graph things, there are 3 possible outcomes. One, you're going to get intersecting lines where they intersect at one point. That is the solution to the system. The second scenario is you'll get parallel lines. That means there's no intersection, so there is no solution. And then the third scenario is you graph both lines and they're the exact same line. They're right on top of each other. That's called an infinite number of solutions because you can pick any point on that line and it would work for both of those. So before graphing, we can tell how many solutions a system would have by putting them in slope-intercept form. If the slopes are different, so I'm going to write up here. So if you get different slopes, this is what you'd get one solution. If you have same slope, different y-intercepts, you'll get the no solution. And if you solve for y and equations match, you get infinite number of solutions. So if you get different slopes, you'll have one solution. If you have the same slope but different y-intercepts, there'll be no solution. And if you have the same slopes and same y-intercepts, which is going to be matching, you get an infinite number of solutions. So without graphing, we're going to tell you how many you have. So the choices are 1, no, or infinite, right? Okay, so we put them in slope-intercept form. If you don't remember, that means solve it for y. So let me rewrite this one over here. 4x plus y equals 24. Very easy to solve that for y. You just have to subtract 4x from both sides of the equation, and we get y equals, flip that around, negative 4x plus 24. Okay, it's in slope-intercept form, nice and easy. Second one takes 2 steps. First, subtract the x. Those cancel. So I have 2y equals, flip that around, negative x plus 2. To get the y by itself, you get rid of that 2 by dividing it. Each term individually needs to be divided. Those 2's cancel. Remember, there's a 1 in front of that x, so it's going to be negative 1/2 x, and then 2 divided by 2 is 1. So let's look. Look at your slopes. Remember, that's the number attached to the x. That's the first thing you look at is the slopes. Boom, boom. Are those slopes the same? Nope. Different slopes. So let's look. Different slopes means one solution. Okay. Number 2, let's look at it. Let me rewrite this one over here. 2x plus y equals 0. All right, to get y by itself, you just have to subtract 2x. It looks like y equals negative 2x. I don't need plus 0 at the end. This one, to solve for y, you just have one step again, divide by 2. Y equals, and then I like the x term to be first, so I'm going to put negative 4 divided by 2 is negative 2x, and then 6 divided by 2 is 3. All right, let's look at our slopes. Negative 2 and negative 2. Same slopes. Let's look at the y-intercepts. They're different. Same slope, different y-intercepts. What's that mean? No solution. Those lines would be parallel. Number 3, let's look at it. Oh, fraction. Oh no. That's okay. All right, let me rewrite that top one. First, move the x over. So I've got negative y equals, in the correct order, negative 8x plus 6. I don't want negative y, so if I change the sign of one thing, I have to change the sign of the other thing. So positive y would equal positive 8x minus 6. That one's solved for y. Second one, I got to get rid of that fraction to start. So we get rid of that by multiplying by the denominator of 2. Half of 2 is 1. We did that on purpose so that the fraction would go away. Y equals 2 times negative 3 is negative 6 plus 8x. Oh, I put that in the wrong order. Let's put it in the right order. 8x minus 6. Look at those equations. They match exactly. Equations match is an infinite number of solutions. It is not all real numbers. That's different. Because not everything. It's just the ones that are on that line. Infinite number of solutions. If you want to pause the video here and try 4 on your own, let's see how you do. Start by rewriting that equation, 6y plus 4x equals 6. Okay, go ahead and solve that one. Pause it here if you haven't done so already. First, you're going to move the x over by subtracting 4x. So 6y equals, in the correct order, negative 4x plus 6. Divide each term by 6. Y equals, that reduces by 2 to negative 2/3 x, and then 6 divided by 6 is 1. That one's done. Second line here, to get y by itself, the first thing we'd move is that 3. So 3y equals negative 2x plus 3. Divide each term by 3. Y equals negative 2/3 x plus 1. Oh, look at that. equations matched exactly again. So that was infinite number of solutions. And that's all I have for you today. So enjoy your second to last lesson. Let me know if you have any questions on my math lab. Talk to you soon.